All right, let's do a few of the 4.4 problems. And number 17 was the first one that people had left blank, and it says to solve for when this r of x is less than or equal to 0. So if we factor 3 out of the numerator, we get 3 times x plus 1. And factor 2 out of the denominator, we get x plus 2. So we're going to have an x-intercept of -1. And we're going to have a vertical asymptote at -2. And if we want to look a little bit further here, we could. This is a single factor, so it's going to go opposite on either side of this. So all we have to really know is maybe the y-intercept and tell us whether it's going this way or going this way. And oh, by the way, the horizontal axis, since it's the same degree, is at the ratio of the coefficients 3/2 or 1.5. So let's find the y-intercept. Put 0 in and 0 in. We get 3 times 1 over 2 times 2, which is 3/4. So it crosses at 3/4, and so it looks like it goes this way and closer there, and if it goes opposite, it must be up here. So if we're looking for when this graph is below 0, that's down here. The only piece is between -2 and -1, and it said equal to 0, so including that. So it's from -2 to -1, including the -1, but not the -2. All right, number 20. At 20, we have a third degree polynomial, and it looks like we have a bounce at -2. And we have a straight through at +5. And we're looking for when this is greater than 0. This is going to be x times x times x, all positive. So it's going to do what a normal cube does. It comes up and down and up. And if it bounces at -2, it's got to look like bounce there and then go down and go back up through 5. And if we want one that's greater than 0, this is not greater than 0, it just reaches 0, so it's equal there. So it would be from 5 and up. And not 5, because that would make it equal. Okay, 23. So if we add 8x squared to both sides, we get 2x to the third plus 8x squared greater than 0. We can factor out a 2x squared, and we get an x plus 4. And so we have cubic again, and it's a positive cubic the way we're looking at it here. So it's going to start down and up, and it looks like it bounces at 0 and it crosses at -4. So if it's coming from below, crossing at -4 and bouncing at 0, it must look like this. And when is this greater than 0? It's greater than 0 from -4 to 0. We're not using -4, parenthesis and a paren here, because it doesn't say equal, and so we have to stop just before 0 and then start right after 0. And from 0 to infinity is the part of this graph where it's positive, it's above 0. Okay, 39. So 39, let's make sure we can see it here. There we go. Two single factors. This has an x-intercept at -4 and a vertical asymptote at +2. And same degree, so horizontal asymptote of 1 over 1 or 1, y equal 1. Y-intercept, if I put in 0, we get 4 over -2, which is -2. So we know that it must go here and down, and since it's a single, it's opposite, so it comes from up here and goes out with that. And if we want it greater than or equal to 1, well, that would be this branch from 2 up. So from 2 to infinity. And we could have brought the 1 over and got a common denominator, but since this had a horizontal asymptote at 1, that was pretty easy to solve just by looking at the graph. Now this one, we've got like 2 hyperbolas here, so we probably want to get it over all on one side here, so we can go 5 over x minus 3 minus 3 over x plus 1, and that would be greater than 0 now. And we can multiply this one by x plus 1 and x plus 1 to get a common denominator. This one by x minus 3 and x minus 3. And we end up with 5x plus 5 minus 3x, and minus 3 times minus 3 is plus 9 over x plus 1 and x minus 3. So if I clean that up, I get 2x plus 14 over x plus 1 and x minus 3. I'm at the bottom of my paper. I want to make sure you can still see that. Yep. Okay, and that's got to be greater than or equal to 0. 2 comes out of that one, be 2 times x plus 7. So, going to the graph, it has a vertical, none of these are like factors here, so we got a vertical asymptote at minus 1. We got a vertical asymptote at plus 3. We have, see, the degree of the numerator is 1 and the degree of the denominator is 2, so this is going to have a horizontal asymptote at 0, y equals 0. And we're going to have an x-intercept at negative 7. Negative 1, 2, 3, 4, 5, 6, 7. Okay, and since these are single factors, it's going to go opposite on this one and opposite on this one. And the only x-intercept is back here at negative 7. And so it doesn't cross in here. So let's see what the y-intercept is. If I put in 0, I get 2 times 7, 14. Over 1 times negative 3 is negative 3. So 14 over negative 3 is down here someplace. So this must go, and since it doesn't cross in here, but it does cross the y-axis here, it must go down here and down here. So it must come back up here and must be up here, and it crosses at 7, but the horizontal asymptote's here, so it must go below and then come up and approach it here. So we're trying to find out when it's greater than 0. From negative 7 down it wouldn't be, but from negative 7 to negative 1 it would be. Can't use the 1, negative 1. It can, but we don't want to be equal, so we can't use the negative 7. Union, this would be negative, not greater than 0. And this part, all of it would be greater than 0, and that would be from 3 to infinity.